Hello, my name is Raj Jogiani and I'm part of the FTC team Round the Cube Robotics 18183, and today I'll be presenting our programming flowchart, which consists of autonomous and teleop. I'll be presenting it in a visual way on a flowchart so it's easier to understand, and I'll explain it in more detail. And let's get to it. Hello, today I'll be speaking about our programming flowchart. In the flowchart, we'll explain how our autonomous and teleop code works. When we first start any of the codes, we first press start and then initialize op mode before the run starts. For robot, we use the start op mode feature to pre-close the cloud before autonomous. And I have put our flowchart snippets on this Google slide. I had to do it in 3 parts because the whole flowchart wouldn't fit. This is the beginning, middle, and end. This shows autonomous, this shows teleop, and this shows teleop. Let's get into it. Autonomous. When autonomous starts, the robot is always aligned between the 2 blue start lines and has 3 rings and 1 wobble go preloaded. This is one of the important key elements for how autonomous works. Then the robot moves towards the rings and scans how many rings there are, 0, 1, or 4 with the camera. After it detects how many rings there are on the field, it drops the wobble go off at one of the 3 squares on the field, depending on the number of rings detected. Then it parks at the launch line and waits until teleop starts. This is the start of the code and shows the code initializing op mode after you have pressed the start button. So this is the beginning of our autonomous. And let's get to teleop. One of our controllers has controls for the driver in teleop, and the other has controls for the shooter. The driver controller controls the movement of the wheels and the intake servo. One of the joysticks are for the direction and the other one is for the movement. The shooting intake controls the shooter, the wheels that are part of the intake, and the shooting flick servo. The shooting intake servo has 2 important joysticks, the left one and the right one. The left joystick controls the intake and the right joystick controls the shooter. This is the beginning of teleop, and this shows that the controllers of the left joystick, like I said, on the driver controller, this joystick performs different tasks based on the direction you want to move the joystick to. This is very important, and this is the visual diagram. This easy-to-read flowchart explains how we have programmed a robot, and now Shamita and Neeraj will do a code walkthrough.
For our wobble go drop off code, we had to set an angle at the arm would drop to when the drop off wobble go object was called. Then our claw would open. We made the claw open by creating an object called claw open that we use the claw control method for.
For the movement of the robot, we use sections based on the detection of the rings and our starting location. As a team, we labeled each tile from A1 to F6. Since this is remote, we had a nice area to choose a starting location. F3 on the right side of the ring pile and F1 on the left. Our goal is to face the rings so the object detection can be accurate.
We have a set starting position based off the diagram we do in our program that is the tile labeled F2. Our goals are tiles C1, B2, and A1. Using the sample code for TensorFlow object detection, we created a program that would use a webcam to look at the stack of rings and detect the height. We created an object height limit of 300 pixels, and if the pixels that the webcam detected were either less than or greater than the object height limit, the program would return 4 rings, 1 ring, or 0 rings if nothing was detected. After that, we have a program based off our starting tile of F2. The robot would move forward to a position that allows the webcam to properly detect the rings, and then use a method that detects the amount of rings. Depending on the amount of rings the webcam detected, the program would run one of 3 options for each destination tile, those tiles being C1, B2, or A1. We use a case statement for this where we would switch the ring value and then return the destination.
After the object is detected, we made it collect data for the destination according to the object detected. We need to be able to control the movement to get to the destination, so we make functions that allow us to do so. For this area, we're making the robot choose a destination according to the amount of rings it detected, and the area of code will not execute the movement, but it's going to tell us which tile it's going to. Therefore, where the return comes in and will tell us on the phone which tile that we labeled. Now that we understand the targeted destination, we instructed the robot on how to do so to get to each and every one of the targeted destinations.
In our shoot at goal code, we use a destination tile that we determined previously in our finding ring count code. We gave time for the motor for the shooter to accelerate. Then we turned on the servo for the flicker that would push the rings up towards the shooter. After the ring was shot out, the servo and the motor would be turned off.
End of our presentation, and this is how autonomous